Lesson: Identifying and assessing risks in AI systems. Identifying and assessing risks in AI systems is a crucial competency for professionals engaged in AI compliance and ethics auditing. The inherent complexity and unpredictability of AI technologies necessitate a robust framework to manage potential risks effectively. This lesson focuses on practical tools, frameworks, and step-by-step applications that can be directly implemented to address real-world challenges, enhancing proficiency in risk management within AI systems. At the core of effective AI risk management is the ability to identify potential risks early in the AI lifecycle. A comprehensive understanding of the AI system's architecture, its data inputs, algorithmic processes, and outputs is essential. One practical tool for this is the AI risk matrix, a framework that allows auditors to categorize risks based on their likelihood and impact. By mapping out possible risk scenarios, professionals can evaluate which risks require immediate attention and which can be monitored over time. This matrix not only aids in visualizing risks, but also helps prioritize them, ensuring that resources are allocated efficiently. Risk identification should be followed by an in-depth assessment. A widely accepted framework for this is the FAIR model, which provides a structured methodology to quantify information risk. The FAIR model disentangles the complexity of AI systems by breaking down risk into four main components: threat event frequency, vulnerability, primary loss magnitude, and secondary loss magnitude. Each of these components is analyzed to determine the probable risk, thus offering a clear picture of potential threats. By applying the FAIR model, auditors can translate qualitative risk assessments into quantitative data, facilitating more objective decision-making. Moreover, AI risk assessment should incorporate continuous monitoring using automated tools. Software such as OpenAI's Safety Gym provides environments where AI algorithms can be stress-tested against various risk scenarios. These simulations are crucial for identifying potential failures in AI behavior, allowing for preemptive adjustments before deployment. By integrating these tools into the risk management process, organizations can maintain a proactive stance on AI risk, continually refining their systems based on real-time data and evolving threats. A practical example of risk identification and assessment can be drawn from the healthcare sector, where AI systems are increasingly used for diagnostic purposes. In 2018, a study published in the Journal of Medical Internet Research highlighted the risks associated with AI-driven diagnostic tools, emphasizing that biases in training data can lead to significant disparities in health outcomes. By employing risk identification frameworks and assessment tools, healthcare providers can ensure that AI systems are tested for biases, safeguarding against potential ethical and legal repercussions. Having identified and assessed risks, the next step is to implement mitigation strategies. One effective approach is the integration of explainable AI technologies, which enhance transparency and trust in AI systems. XAI tools provide insights into the decision-making processes of AI algorithms, making it easier to identify and correct biases or errors. For instance, Lime and SHAP are popular XAI tools that offer detailed explanations of AI model predictions, assisting auditors in understanding and communicating the rationale behind AI decisions. In addition to technical measures, establishing a robust governance framework is crucial for comprehensive risk management in AI systems. The AI auditing process should incorporate ethical guidelines, regulatory compliance measures, and clear accountability structures. The IEEE Global Initiative on Ethics of Autonomous and Intelligent Systems provides a comprehensive set of guidelines that can be tailored to specific organizational needs, ensuring that AI systems are not only technically sound, but also ethically aligned. Training and education are also pivotal in enhancing risk management practices. Professionals should be equipped with the knowledge and skills to navigate the complexities of AI systems. Continuous professional development programs, such as workshops and certifications, can keep auditors abreast of the latest advancements in AI risk management tools and methodologies. This ongoing education fosters a culture of vigilance and adaptability, essential for mitigating the dynamic risks associated with AI technologies. Furthermore, Collaboration and information sharing among stakeholders can significantly enhance risk management efforts. Platforms that facilitate the exchange of insights and best practices, such as the Partnership on AI, enable organizations to learn from each other's experiences, refining their risk management strategies based on collective knowledge. By fostering a collaborative environment, organizations can better anticipate emerging risks and adapt their strategies accordingly. Case studies offer valuable lessons in AI risk management. A pertinent example is the deployment of AI systems in autonomous vehicles, where risk identification and assessment are paramount. In 2018, Uber's self-driving car incident underscored the critical need for rigorous risk evaluation in AI systems. The subsequent investigation revealed gaps in the AI system's ability to accurately identify and respond to unexpected obstacles. This case highlights the importance of comprehensive risk assessments and the integration of fail-safes in AI systems to prevent similar occurrences. In conclusion, identifying and assessing risks in AI systems is a multifaceted process that requires a strategic blend of tools, frameworks, and methodologies. By utilizing frameworks such as the AI Risk Matrix and FAIR model, employing tools like SafetyGym, and adopting explainable AI technologies, professionals can effectively manage AI-related risks. Establishing robust governance frameworks, fostering continuous education, and promoting stakeholder collaboration further enhance risk management efforts. Through these strategies, organizations can navigate the complexities of AI systems, ensuring their safe, ethical, and effective deployment.